Hey there. All right, this lesson is going to go over Algebra 1's graphing functions using a table. All right, this covers a couple different targets, or part of them. Target 2, identifying inputs and outputs of a function, pretty straightforward. And then target 3, where we're identifying whether a function is linear, quadratic, or exponential. And we're doing that by completing its table and graph. So that's really what we're going to work on today. Equation and function notation. Not in function notation today, not a big deal, but we're going to talk about completing a table and a graph for a function. All right, so here we go, our first problem. So here's my function, y equals 4x minus 1, and my end goal is to determine whether it's linear or nonlinear. Okay, but the way I'm going to do that is I'm going to generate a table using this function, and I'm going to graph it, and then I'll use those two things to determine whether it's linear or nonlinear. Okay. So first of all, looking at our table in general, when we're graphing or dealing with any kind of a function where y is y is a function of x. Okay. Our x values are always our inputs. Okay. And this is pretty typical for graphing on the coordinate plane as well. All right. We have our x-axis, we have our y-axis. All right. Our x is our inputs, and then our y is our outputs. I'm not going to have a lot of space here, but I'll sketch it in there. Okay, so what I'm going to do is I'm going to take this function, and I'm going to find some inputs, okay, for x. Now, generally, it's a nice idea to use 0, and then we often want to do some negative values for inputs and couple positive values for our inputs, okay, in general. Now, we could pick any number in theory, kind of plug it in, but these are nice ones usually to choose, okay. So here's how it works. I take an input, so I'm going to start with this input of -2. I'm going to go over to my function, and I'm going to put -2 right here for my x value. I'm going to replace it, okay. So here's often how I write any of these functions. I'm going to do y equals 4, and now it's times x. What I do is I put a parentheses there around the x because I'm going to replace that. I want to multiply by whatever I put in there, okay? And then minus 1, all right? Yeah, I don't like that there. Okay. The reason I do that is because it often works out nice with a calculator, especially with complicated functions, all right? But this one's fairly straightforward. So I'm taking -2, and -2 is my input. And so to find the y value or the output that goes along with it, I solve this. I figure out what this expression over here is. So 4 times -2 is -8, and then minus 1 would be -9. Right. So when my input is -2, my output is -9. I'm going to show you that on a calculator. So I would do 4. Here's my parentheses where I bring this in, okay, and -2. So it's 4 times -2 minus 1. Now you can do this on your TI calculators as well if you have one of those, and it's really nice. You can put that whole thing in there at once, okay. And then what you can do, even, is you can go back here and say, okay, now I want an input of -1. All right. Well, I'm just going to change that. So now my input is -1. And look at that, I can output -5. Okay, so I'm going to come back here, and my output is -5. Okay, so you can rewrite this every time if you want to, right, and change this input value. Okay, you can use your calculator to be kind of more efficient with it too, right? So again, I'm going to find my output this time when, when my input is 0, right? I input 0 here. Okay, and -1, that makes sense. 4 times 0 is 0, minus 1 is -1. Okay, I needed an input of 1, so I'll plug that in. And again, these you can probably do quickly in your head too, maybe even faster than this, which is totally fine, but I just want you to see how I'm kind of doing this using the power of the calculator. Input of 2, I get 7. All right, so let's see, I had -1, and then 3 and 7, so I'm going to plug those in. -1, 3, and 7. There we go. That's all there is to it, generating a table. And again, these are often some of the values we use for our inputs. But you take your input, you plug it in for that x value, and solve that part of the equation to find what your y value is, your output, okay? All right, I'm going to go ahead and plot these right away. So -2, -9. All right, -2 is my x value. Here we go, over -1, -2, and then I need to go down 9. That's 3, 6, 9. Okay, -1, -5. So -1, -1, 2, 3, 4, 5. Okay, 0, -1. So 0, I'm not going to move to the right or to the left, but I have to go down 1. Okay. 1, 3, so 1, and then 3 is positive, so I go up. 2, 7, over 2, up, 5, 6, 7. There we go, and that's all there is to it. So I took those points generated from my table by plugging them into the function, and I plotted them on the graph. All right. So now I can think about linear and nonlinear. What I want to try to do, though, is graphically I want to see if I can draw a line through them. So let's, oh wait, did not want to do that. Let's see. Let's try this again. No, try this again. Give me a line tool. There we go. There we go. All right. So here's my line. I want to see if I can get that to go through all the points, right? Do they all lie on a line? And yeah, in this case they do, if I can get it to stick there. All right, so I'm going to say this one is linear because looking at the graph, those points formed a line. Okay, so linear. Okay, the other thing I look for, and we can find it by the table now as well, which we've kind of talked about, I think, a little bit. All right, if I look at the change when my inputs are increasing by 1, is my change constant? And in fact, it is. I'm increasing by 4, plus 4, plus 4, plus 4. That's a constant change each time. And I can see that on my graph too. I'm going up 4 and over 1, up 4 over 1, up 4 over 1, up 4 over 1. That's constant. That happens with a linear function. Okay? All right. So that's it. Function, complete the table, put the points on so we can see the graph. All right? We're going to do one more. All right. So here's my function. All right. Again, these are my inputs that I'm going to do, and these are my outputs that are going to come out of this function. So my inputs, again, I'm going to use these. Okay, again, you don't have to. In fact, sometimes you might want to even do more than that. You could do 3, 4, 5. You could do -3. You can do as many as you want. Right? The more you do, the more accurate your graph will be. I'm just going to use these for now. Okay. So here's my function. I'm going to rewrite this one. So y equals, now again, I like to put this in parentheses, right? So in this case, I'm taking x and I'm squaring it. Okay, so I'm going to take my x value, I'm putting it in parentheses, I'm going to square it, and then subtract 7. Right? So I'm going to take these inputs and I have to put them in there. Okay, because those are my x values. I'm going to replace x. So I'm going to start with -2. All right, there we go. I'm going to pull up my calculator for this one right away. And here we go, parentheses. Again, your TI will do this for sure if you have that. So I have -2 and I'm squaring it. Okay, I'm not multiplying by 2, I'm squaring it. So I have a little key here that'll do it. Your calculator has a little caret button, we call it too, where we can do powers. All right, we can show you that, but I'm just going to do that one. So this little caret means to the power of, or it tells me it's an exponent. So -2 to the power of 2, and then I have to subtract 7 as well. So I'm going to do that right away. -7. All right, so this has an output of -3. Input -2, output -3. Okay. I'm going to go back to my calculator, and I'm just going to change my input. I'm going to try -1 and see what happens. So again, I'm just going to grab my function, and I want -1 instead. And I get an output of -6. Okay. I'm going to do 0 right away while I'm here, and then I'll write those down so I don't forget them. Just scoot over there. There we go. So 0, well, 0 squared is 0, right? And then -7, so this should be -7. Yeah, there we go. All right, I'm going to write those in so I don't forget. So this was -6. This was -7. All right, now I have 2 more. I'm going to try an input of 1, input of 2. Okay, so here we go. not 0, but an input of 1. So 1 squared minus 7 is negative 6, okay? And 2 squared minus 7 is negative 3, okay? So negative 6, negative 3. Well, so there's a little pattern going here. Here's the thing we can see right away, though. This one's not going to be linear. Looking at the table, I can see it already, and maybe you can too, because these changes are not constant. Right? I'm going down a little bit less, and then I'm starting to come back up. Okay, so let's plot these points just to really convince ourselves. Negative 2, negative 3. So negative 2, negative 3 is down there. Negative 1, negative 6. Negative 1, negative 3, 4, 5, 6. 0, negative 7. So 0 means I'm not going to go to the right or left, but I have to go down to negative 7. 1, negative 6. So positive 1, negative 6. And 2, negative 3. All right. Definitely not linear, right? So what the heck does this look like? We're actually going to do more of these second semester, but I'll give you a little preview. This thing is actually what we call a parabola. It's a graph it's going to end up looking like this. So like I said, if you did some more points, like if you did some more inputs here and here, you're going to get more of the graph and you'll see. But that's kind of what it's going to be. So for all intents and purposes right now, we're trying to determine linear or nonlinear. And this one is definitely nonlinear. And like I said, we can find that from the table because there was not a constant change. And we can clearly see it on the graph as well. Those points do not form a straight line, and there is definitely not a constant change in this graph. Okay, and there you go. That is graphing functions with a table.